Good afternoon, students. Let's see an example for topological sort. Here I have taken a directed acyclic graph P having multiple nodes like A, B, C, D, E, F, H and G. Firstly, I will tell you about what is DAG or directed acyclic graph. A graph that is having directed edges, but the sequence of those edges will not create a cycle. See, in this graph, if I'll take the sequence of directed edges like BC, CE, EF, but there is no directed edge between F and D or D and P. So it will not create a cycle and thus it is a directed acyclic graph. So let's proceed for the solution of example. To solve this problem, I have taken two data structures. First data structure will keep the visited nodes and the second data structure I have used is the stack data structure that will keep the sorted nodes. Means I can pick up the sorted sequence from the stack in the reverse order, since all we know that the stack has property of last in first out, means the data which is gone in the last will come out first, right? So let's start. Here we will randomly take some node to start with. Suppose I have taken a node E where I have marked an arrow. So I have taken node E and I have visited that node. So I'll keep that node in the set of visited nodes, right? See here I have placed this node. See, initially the sorted node stack is empty since we have taken just one node here and it is not sorted yet, right? The main idea in the topological sorting is that we will consider each node one by one and we will see whether that node is having some children or not. So two cases will arrive here. If the node is having no children, then we will directly keep that node in the set of sorted nodes. But secondly, if the node is having some children, then we will explore those children's, and after the exploration, when we will find that the node is left with no unexplored children, we can keep that node in the stack, right? So accordingly, I have kept E in the set of visited nodes and initially the sorted node set stack is empty, right? So here at E, I will see whether E is having some children or not. So from the graph, I can see E is having two children. So I'll start exploring these children, but I will start exploring them randomly. Either I can keep H first or F first, since we know that the topological sorting is never unique, right? So I have decided to keep H in the set of visited nodes, means I'll take H first, right? So I took H in the set of visited nodes, right? Next, I'll see whether H is having some children or not. From the graph, I can see H is having no children. So accordingly to the criteria, as I have told you earlier, the node that is having no children can be kept in the sorted node stack. So I keep H in the sorted nodes stack, right? Next, I'll see after exploring H, I'll see the next node which will come into the path is node E that I had already explored, and now I will see that the node which had been explored already is in the visited nodes, so I will not take it again. So I'll go to the children of E, that is node F. So I'll determine that F is the node having one children G, but before that I'll keep F in the set of visited nodes, right? And then I'll go to the children of F, that is node G. I'll also keep G in the set of visited nodes. And then I'll see that whether G is having some children or not. Since G is having no children, so I'll keep G in the set of sorted nodes, right? Again, after exploring G, I'll again back to the F. Since F is already in the visited nodes, so I'll not put it again. But I will see whether F is having some children or not. Since f is having one children and that had been explored already, so I can put f in the set of sorted nodes, right? Similarly, I'll go to the E and see whether the children had been explored already. Since they had been explored, so I'll put E in the set of sorted nodes, right? So after finishing up to this point, I'll again pick some another node randomly to start with. So I took the node B. The node B is firstly kept in the set of visited nodes. Then I start seeing whether B is having some children or not. Since B is having two children, C and D, so I randomly took C first and I kept in the set of visited nodes, right? So I'll see then whether C is having some children. Since C is having only one child, that is E, and that had been explored already and is already in the set of sorted nodes. So I'll put C into the set of sorted nodes, right? So I'll again go to B and I'll find that B is having two children. One children I had explored and the rest is child D. So I'll put D in the set of visited nodes and I'll start seeing whether D is having some other child or not. Then D is having a child F, but you'll find that F had been explored already and is already in the set of sorted nodes. So I'll not take it here. So I'll put D first in the set of sorted nodes since it is having only one child and that had been explored already, right? So I'll go back to B to determine whether it is having some unexplored child. Since it is not having any unexplored child, so I'll put B into the set of sorted nodes, right? So in the end, I will be left with only node A. Since node A is having child C that had been explored already, it means A can be kept in the set of sorted nodes. And the final topological sort will be, since this is a stack, we will keep the elements in this order: A, B, D, C, E, F, G, H, right? And I had already told you that it is not unique, so you can have some another topological sort for this problem. Thank you.